Hi U10s, in this video I'm going to be going through pages 6 to 12, so part 2 of your Algebra and Linear Relations revision. So let me get started. So if you want to watch anything from page 1 to 5, that's on my YouTube channel, and you should have the link to that as well. All right, so on page 6, we're starting to look at some applications of linear equations, and you can see here it says that Freddie gets paid $20 per day. Oh, let's underline that. And $8 for every car he washes. So this is write an equation for his daily pay. So usually we would have, y is some function of x, mx plus c. Well, this time, instead of the y being the dependent variable, then y, we want pay, and pay is going to depend on how many cars she washes, which is n. So if we have n for every car he washes, and of course $20, well, first of all, the constant 20, they're going to get that no matter how many cars they wash. And of course, well, now we have to find, well, where's the gradient going to be in this linear equation? And it's right here, $8. So if I was to multiply n, the number of cars he washes, times that by n by 8, then that's going to be my equation. Okay, so, and it now says use the equation in A to determine his pay after washing 11 cars in 1 day. So we would just have to simply substitute that. When n, now obviously we want you to not just guess and check, and we want you to actually use an equation. When n equals 11, then p is equal to 8 times 11 plus 20, which is 88 plus 20, which is 108. $108 for washing 11 cars. And of course, this 20, this constant here, is always going to be there, isn't it? The constant. But the variable, n, is obviously changing. Requires him to earn at least $120 per day. What is the minimum number of cars he must wash to meet his target? Well, what we can do is we can let, this time, we can let P equal 120. And what we can do is let's solve for n. How many cars? Now, if I go ahead and throw that into my equation that I got in A, then we've got 120 is equal to 8n plus 20. If I subtract 20 from both sides, we've got 100 is equal to 8n. And if I divide both sides by 8, we're going to get, well, what are we looking at? We're looking at n is equal to 100 divided by 8 now. 96 divided by 8 is 12. So it's going to be 12.5. Now you can't wash half a car. You'd at least make that assumption. So, of course, $120 is not 12.5 cars. Then what we're going to have to say is we're going to have to round up, and therefore, in order to earn $120, we're going to round up to the nearest car. So what we would say is that there'd be 13 cars washed. Okay, so we have to have a discrete value, a whole number. So in this case, if we solve and we get 12.5, then we're going to have to round up to 13. All right, so look, hopefully that is a pretty straightforward linear relationship. And instead of y's, x's, and y's, x's, and c's, and m's, then we still use the same principles, but of course this time we're looking at P for pay and N for the number of cars. All right, now let's have a look at page 7. Now, we've got a few lines, and of course this here is the origin. And it says we've got two equations. Now these two equations are not in y equals mx plus c form, but they could quite easily become y equals mx c form if I was to subtract 2x from both sides. So if I was to do that, I would have 8 minus 2x. And over here I would have y is equal to 4 minus 2x. Now, we've been told that O is the origin, A, B, C, D are intercepts. So let's have a look. Which one of these is going to have a y-intercept of 4? Well, that would be this one here. So clearly these two have the same gradient. They look like they're parallel, and that would agree with the fact that they have a gradient of -2. So, well, let's label these. Well, this is going to be 0, 4. This B is going to be 0, 8. And likewise, if I have it like this, then in gradient intercept form, then of course we can find the x-intercepts because of course C and D are going to be when y is equal to 0, aren't they? Okay, so what we're going to do is we're going to be very careful. We've got to use, to find D, we're going to have to use this equation here. You could use this one as well. You could set y equals to 0 and it's still going to work. And as I reckon if you could do that, look at that. If y was 0, that cancels out. 2x is equal to 8. So that means that x would be equal to 4. So let's put that in. There you go. That's 4, 0. And likewise over here, well, if I could throw it into here if you like, the x-intercept. We'll let y equals 0. This time I'm going to use the rearranged equation, and of course I could then add 2x to both sides, and that's going to give me 2x is equal to 4, which means of course x is equal to 2. So there you go, right, the coordinates for the 5 points. Well, clearly A is 0, 4. B is 0, 8. C is 2, 0. D is 4, 0. And of course, the origin is 0, 0. Shade the area bound by the two lines and the x and the y axis. Okay, so let's have a look. If I was to do that, let's get my highlighter out. Now it says shade the area bound by the two lines and the x and the y axis. So what we're sort of looking at is we're looking at this shaded region here. Obviously we're looking at the area between the two lines and we're looking for this area here. Well, how would you find this area? Well, if I was to do, we've got a big triangle here. Let's have a look. Find a big triangle here. That triangle. And then if I was to subtract, so if I was to have that triangle, and then I was to subtract, let's call that triangle 1. Okay, that's the really big triangle, which goes up here, and it goes sort of across my base would be here. And triangle 2 would be this one in here. I might sort of, it would go in here. All right, so how do we find that green shaded region? Well, we could find the area of the big triangle and we could subtract. Let's have a look. Find the areas of, so we've shaded the region and find the areas of the triangles OAC. So it's sort of telling us what to do in if we like. So the area of a triangle, by the way, that's a half times the base times the height, hopefully you remember. And OAC, so what's the base? Well, for here, so the triangle OAC, so for triangle OAC, that area is a half times the base. Well, what's the base? That's a distance of 2, isn't it? So it's a half times 2 times what's the height? Looks like it's a height of 4, 0, 4. Okay, so if you like, we've got 2 times 4 is 8. half of 8 is 4. So that is going to be 4, we'll call it units squared. Now that's for triangle OAC. If I had triangle OBD, then we're looking for this triangle up here. Okay, so we're looking for this one. There's my height. There's my base. So that's 4 times 8, and we're obviously multiplying that by a half. 4 times 8. Well, 4 8s are 32. Half of 32 is 16 units squared. So hence find the shaded area. Therefore, the shaded area is that green one. And if you think about it, if I have the big triangle and I subtract the small triangle away from it, then the area that's shaded in green is going to be that. So in other words, it's going to be 16. And it says, look, it says hence. So hence means that you need to use your answer to the previous question. Here's my two triangle areas, and we need to subtract the 4 from 16, which of course is 12. Doesn't look like we've got any units like meters or anything, so that is done. Obviously, it looks a little bit different, but there's nothing too crazy about this question. You just got to read and interpret it and take your time. All right. Now, let's have a look at, in particular, in past years, a lot of students, although they do pretty well with this stuff when they get the hang of algebraic fractions, because it's the first topic or the first subtopic we did, a lot of students just don't revise for these anywhere near as well as they should. So please make sure that you have some examples like this in your bound reference. Okay, it's in your revision pack for a reason. You're going to get questions like this. Let's go through it. Now, the first one is I've got to solve this equation. Now, look, I'm going to put brackets here. Like everything, the reason why I do put brackets is because remember in BODMAS, we always, when we evaluate in the opposite direction. So, sorry, we evaluate here going down this way, but when we're solving, we're doing it in reverse. Now, a lot of people will think of addition and subtraction, because there's a subtraction in here, then they can do that. No, because it's in the brackets, we do the brackets last. So if you like, that 2x minus 1 is divided by 3. So what is the opposite of divide by 3? It's times by 3. So let's times 3 to both sides. And if I do that, that's going to cancel out my fraction. I'm left with 2x minus 1 is 15. And obviously you can finish that off, can't you? 16x is equal to, dividing by 2 is 8. Okay, so that's all we need. Over here, again, let's put some brackets in here. Don't deal with addition and subtraction. Well, the right-hand side is divided by 3. The left-hand side is divided by 4. Let's do the inverse of that. Or we could just do cross multiplication. Okay, so anything in the numerator on one side could go on the denominator of the other, and vice versa. So of course it's going to make sense. If I get this 3, let's get this over here. Okay, so let's get this 3 over here, which is x plus 2. And let's get the 4 over here. Now, of course, now I can expand them out. Let's do that. 3x plus 6 is equal to 8x minus 4. Let's leave the greatest value of x and let's subtract x from both sides, or 3x from both sides. And when I do that, that's going to eliminate that, and we're going to be left with 5x take 4. Now, if I add 4 to the other side, it gives me 10. 5x equals 10. If you went straight to the answer, I'm cool with that. X is equal to 2. Okay, because 5x is 10. All right, you've shown enough key steps. You show me that you can cross multiply. You can show me you can expand brackets, subtract 3x from both sides. If you went straight to the answer for them, you don't have a calculator in this section of the test. Okay, so I get that you don't necessarily need to show all the working. All right, now let's have a look. It says simplify. Now, whenever you're simplifying, well, we need to factorize, okay? We can factorize. Now, let's have a look at the top and the bottom. What you should be able to notice, hopefully, is if, let's factorize the thing on the, let's factorize this. What does that have in common? Well, it has a 3, they both have a 3 in common, and let's see what goes inside the brackets. X plus 2. Okay, so let's have a look. The highest common factor of 3x and 6, the highest common factor is 3. That's what we're doing. We're factorizing, taking out the front. And the reason why we do that, because I'm not going to do anything there, I'm going to leave this, is I'm going to factorize the bottom. I'm going to factorize this. If I take 2 out, what does it have in common? X plus 2. 2 times x is, so as you can see, what's going to happen now? Well, we've got an x plus 2 on the top, we've got an x plus 2 on the bottom, and those, of course, we're multiplying. So when you're multiplying, if you've got, you can cancel those out, can't you? And likewise, we could work our way across and we could work our way down. It's really up to you. If you wanted to, you could go that 6 goes into 18 3 times, and then we could go across. 3 times 3 is 9, and we've got a 2 left on the bottom. So there you go. 9 over 2 is your answer. Okay, so we've actually cancelled out those values of x. Now, this is where a lot of students, we see this, and of course, the first thing you should do, if you've got 2 fractions, you've got to find the LCD. If you've got a pronumeral, like an x or something like that, then it's a lot harder. You'll have to multiply the 2 to get the LCD. But of course, 3 and 4 just so happens to be, if I multiply them, that 3 times 4 is 12. So the lowest common denominator is actually 12. Doesn't always work, because what happens if I had 3 and 6? Well, the lowest common denominator isn't multiplying the 2 together. It's actually going to be, if I would just have to multiply this by 2 to get 6. So the lowest common denominator is 6. Okay, so obviously it's going to work if you're multiplying, but is it going to be the lowest? Well, in this case, yes, 3 times 4 is 12. So it will work, but you just got to be really careful that you're not creating more work for yourself. All right, so if you look at this one, I want this to be a 12 and I want this to be a 12. If you establish what the LCD is, I might even give you half a mark if you didn't go any further. What does that mean? It means, let's open up a bracket. I've got to multiply this one by 3. Okay, I'll just do that as plus 12. I'm going to multiply this one by 4. Notice that I'm opening up a bracket. Okay, now we can bring that all together now. That's all over 12. Let's expand this out, and let's bring it all together. 3x plus 15 plus 8x minus 4. And that's going to give me on top, well, we're going to collect like terms, don't we? We've got 3 xylophones plus 8 xylophones is 11 xylophones plus, what's that, 11 over 12. I'm just going to rub this out because it looks really a little bit messy. Okay, so look, we really can't simplify any further than that. That is now simplified. Okay, now we're starting to get and looking into like repeats of the questions we've already been through in the first video. Okay, so we're on page 8 at the moment. Let's have a look at this. Consider these lines. We've got one, two, 3 lines. 2 of them are in y equals mx plus c form, but this one isn't. Okay, so we're going to have to, we might have to deal with that in a second. Now it says state the gradient of each line. Well, clearly we can see that the gradient of this line 1 is 2 because, of course, there you go, y equals mx plus c. M is the gradient, isn't it? Okay, what about 2? Can you determine the gradient in this form? No, you can't, because it's not in gradient intercept form. So let's rearrange it. We've got 2y. I'm going to subtract x from both sides, get it on the other side. Then I'm going to divide both sides by 2. Now, if I divide that, that's going to be 4 minus x over 2. Now, of course, we could simplify that a little bit further, because 4 divided by 2 is just 2, and then it's just minus x on 2. And notice, what's the gradient of x here? The gradient's the thing in front of x. Well, the gradient would be equal to -1/2. Okay, so the gradient for 2 is, we had to do a bit of rearranging, but it's negative 1/2. That's the number in front of x. And of course, for 3, we know that the gradient there is 2. Okay, there's my gradient. Line 1 is parallel to which line? Well, we know that it's parallel, so 1 is parallel to 3, because why? Well, because it has the same gradient, which is of course 2. Line I is perpendicular to which line? Well, you can see that now that we've got, if I go number 2, I'm going to call this Y2. Okay, and that's going to be, we've rearranged it up here. We've rearranged it up here, so you can see that that is y is equal to 2 minus x on 2. So what would be the gradient of that? Well, the gradient we've already established is minus 1/2. So line 1 is perpendicular to which line? Well, we know that if I do M1 and I do M2, and line 1 has a gradient of 2, and if I multiply that by negative 1/2, which we can see we've already worked that out up here, then that's going to be, well, 2 divided by 2, that's going to cancel, aren't they? And we're left with minus 1. So y is, so line 1 is perpendicular to 2, since, use a bit of math language here, since M1 times M2 is equal to negative 1. That's all you need to write. And look, surprise, surprise, you get questions like this sort of coming up each year, and you just need to make yourself familiar with those. Do you need to absolutely get every concept down to the nth degree? No, I think that sometimes there is a little bit of rote learning. There is a little bit of rote learning, but obviously the more you understand the concepts, the more likely you are of getting the more challenging questions that are simply just not rote learning. But likewise, you could here, if you see something similar, hopefully you can be able to repeat the dose and be able to do it in a test. Okay, so look, I'm going to keep going. I'll probably do a couple of pages and then I'll stop. Sketching, you're going to have these each and every year, and you're going to have sketching of the 2 different types. So of course, first of all, we know that y is equal to mx plus c. We know that the gradient is minus 3. We also know, because this is in intercept form, this is the y-intercept. Okay, which of course in this case is not 6, it's minus 6. Okay, we also know that it's got a negative gradient. So if I go down to minus 6, and I'm going to put it down here, let's say down here. So we're going to call that 0 minus 6. Okay, and if you like, we know that it's going to be a negative gradient. So let's sketch a line, something like that. Now, we've got to find the intercept. Now, yes, indeed, we know that because the gradient is minus 3, that means that every time it goes across 1, it goes down 3. How would it go down 6? Well, naturally, if you understood that concept of the gradient, it would have to go across 2 and down 6 from that intercept, wouldn't it? So that would be negative 2 and, of course, 0. Or we can say that the x-intercept, we let y equal 0, and we solve for x. So it's 0 is equal to minus 3x minus 6. Let's add 6 to both sides. So we've got minus 3x is equal to positive 6, dividing both sides by negative 3, x is equal to negative 2. You can do either. That's fine. Just remember though, you're not always going to get nice whole numbers, which doesn't necessarily make it, yes, we can hopefully see, if I get my red pen out, hopefully you can see that yes, it goes across 1, down 3, across another one, down 3, which means that that would have to be my intercept at -2. Now, over here, when it's in this form, my advice would be, yes, you could rearrange the equation. I have no doubt about that, and that's going to be easy to find the intercept. But what we'll do is, why don't we just do it like this? Leave it. We know it's a linear equation in disguise. Why don't we just find the x-intercepts by letting y equal 0? Now, if you think about it, if that was equal to 0, that means that would just scrub that out. You'd be left with 2x equals 18, which means x is equal to 9, isn't it? So if I put an x equals 9 over here, 9, 0, and we only need 2 points on the line. So if I was to rearrange, if I was to stop this now, we've found the x part. What does the y-intercept equal? The y-intercept, we let x equal 0. So imagine if I scrub that out, what am I left with? 6y is equal to 18, or y is equal to 3. Okay, so y is equal to 3. So you can see there that we've got a line with a negative gradient. Okay, so it's 0, 3. And in actual fact, it's going to not be as steep, and we can sketch a line between those 2 points, like so. What's the other way? It is longer, and we were probably more prone to making mistakes, but if I wanted to get y by itself, I could subtract 2x from both sides. And if I did that, I'm left with 6y is equal to 18. Take 2x, divide both sides by 6. We're left with y is equal to 18 minus 2x divided by 6. 18 divided by 6 is 3, minus 2 6 is like 1/3, isn't it? So we'll call that x on 3. So you can see here, look, there's my y-intercept, 3, and here's my gradient. It's negative 1/3. Not negative x on 3, it's the coefficient of x. So what does that mean? If I go across 1, I go down a third. If I go across 1, I go down a third. And if I went across 9 from here to here, I would actually go down 3 places. Okay? What's the easiest way? I think the easiest way is when you have it in this form to find the x-intercepts and the y-intercepts and join the dots. Okay, the first method that I've shown you. Okay, it's still a little bit more graphic, but this time we're looking at some special ones because it says x equals 5. Now, of course, these ones are not in your y equals mx plus c form. Okay, so we can forget about that. But again, nice to learn. It can help to some degree, but x equals 5. One of these is a vertical line and one is a horizontal line. Well, first of all, let's mark out what our x and mark out our y. If I was to have x equals 5, let's say there, then if I wanted to have all the values that x equals 5, I'd have to go up in a straight line, wouldn't I? So x equals 5 is actually a vertical line which goes through 5, 0. This is x equals 5. Now, the other way, if you wanted to, we could almost use y equals mx plus c form, but y equals minus 2. Now, if I think about it, if I've got minus 2 as my constant and like a 0x, notice there that the gradient would be 0. Okay, if the gradient's 0, a 0 gradient, think about if you're riding a bike and you have 0 gradient, you're riding on a flat surface, aren't you? There's no rise, you just literally that the run is in this direction, and there's no rise and there's no fall or anything. So as you can see, gradient of 0 means that would be a horizontal line, and let's do that. And you can hopefully use a ruler and make it look much neater. But you get the idea. This is supposed to be a straight line going through y is equal to -2, and it's going to be what we call a horizontal line. Okay? All right, Let's see how long has the video gone for so far. I don't want this to go. Okay, so look, the video's gone half an hour. I'm just going to go through page 10 and we'll call it a day. And by the time you've been through the first 10 pages, you really have covered pretty much all of the skills. These ones can trick people because you sort of got to read and interpret. Now, point A has coordinates -3, 5. Point B has this, and point C is this. Find the exact value of the distance between A and C. Okay, so first of all, hopefully you've gone to your formula sheet, and if you haven't remembered, then we can say that the distance between 2 points is we're using Pythagoras' theorem. And what we have is we have this. It could be x2 take away x1 squared plus y2 minus y1 squared. I could draw it, but I don't feel the need. I don't have to. One thing we always do is also treat x1 and y1 as the point on the left. So A and C, notice that this one here, if I was using these two, then this is the point on the left because this is the smallest x value. -3 is smaller. So x1, we'll call that x2, and we'll also call that y2, and of course that's y1. Okay, now let's go ahead and throw our numbers in, and we can use our rule. So we've got x2 take away x1. Be very careful to subtract -3. All right, can you see that? We're subtracting this thing, which means it's subtract the difference between those 2 points is not 2 take away 3. It's 2 take away -3, which is indeed 5, which we'll get to in a second. Okay, we'll get to that in 1 second. Be very careful with the negatives there. Likewise, we're going from 6 take away 5. So 6 take away 5, and that's squared. Now let's do it. As I mentioned, these are a negative and a negative becomes a positive. 2 plus 3 is 5. 5 squared. 5 squared plus, well, that's 1 squared, isn't it? Is, let's leave it in an exact value, which it's asked us for, which is the square root of 26. Okay, now it says the midpoint. Again, use the rule, but this time be very careful. We've been asked between B and C. All right, so B and C. Let's have a look. B has coordinates this. So if you like, I'll just consider this time. We'll call this x1. We'll call this y1. We'll call this x2, we'll call this y2, and again the midpoint is the average of the 2 points of the x and dividing by 2. If I want to take the average of 2 points in the y, I'm getting y1 and y2, adding them together and dividing by 2. Now, of course, we have some values for that, don't we? We've got 0 and 2 as x1 and x2, so it's 0 plus 2 divided by 2, comma 8 and 6. So 8 plus 6 divided by 2, which of course is 2 divided by 2 is 1, 14 divided by 2 is 7. Look at that. Not so bad, is it? Pretty straightforward enough concept. If you've got the rules in front of you, great, but you should really have examples in your bound reference, more just so you know what to expect. A lot of students, they have working lessons, they do 5 minutes of work in 40 minutes, half an hour, and then all of a sudden they just think they're just going to be able to sit down for 50 minutes and do maths solidly. So it's really important that hopefully you are practicing in time conditions and you know your stuff. So yeah, please, this whole revision booklet you need to complete. Okay, not just by watching a video, by actively trying the questions and reflecting on what you don't understand, asking your teacher for help, and creating a bound reference. All of these things are what makes a really good math student. Okay. L1, the equation of line through A and B. Okay, so let's have a look. We've got point A. Let's say point A goes through here. So point A, let's write it out. So we've got a line that goes through these points, goes through here. Well, that's actually pretty nice because if it goes through those points, you notice what this is? This is the y-intercept. Okay, can you see that? That's the y-intercept. Y-intercept is when x equals 0, isn't it? That's the y-intercept. So if I've got a line that I'm trying to find the equation for, well, we've already been told what that is. That's 8. Now, if you don't recognise that, there's other ways to do it. Let's go at it now, though, and let's find the gradient. Okay, we know that the gradient is the rise over the run. And of course, you don't need to write it like that anymore because we can say x1, y1, x2, y2. So let's do that, the rise. Well, it's y2 minus y1, 8 take away 5. And x2 take away x1. Be careful, what is a negative times a negative? It's a positive. 8 take away 5 is 3, and then we're looking at positive 3, so that's going to be 1. And look at that. We now have our gradient, we have our gradient, and we have our, so gradient is 1, so it's 1x or just x plus 8, and that is our equation, which is, of course, we're calling it L1. And finally, we're going to finish on this one. L2, the equation of the line parallel to 1 but passing through C. So if it's parallel, then L2, you know, we're talking about, we'll call that y2 is equal to mx, but hey, if it's parallel, it has the same gradient. Okay, so it's the same gradient as this one. So it's going to be x plus, we're going to call that c. Passing through C. Now, what is the passing through C? C has the coordinates of 2, 6. So what we're going to do is we know that it's going to have this, but when x equals 2, y equals 6. Let's substitute that in and let's find what the values are. We've got 6 is equal to 2 plus c. So you guessed it, c is equal to 4. So therefore we can say that L2 is the line such that y is equal to, again, it's x, but instead of plus 8 as it was before, it's plus 4. How could we also test, does the point 2, 6 satisfy the equation? Well, does, when x equals 3, does y equal 6? Is this true, or when x equals 2? Is that true? Yes, it is. So that, of course, goes through that point, and it also happens to be parallel. All right, I know that it's a lot to take in. There's a lot of concepts we're revising. This is the hardest concepts, the hardest topic for semester 1 by a mile. Okay, students really can struggle revising all of these concepts. So what I'm going to do is I'm going to stop there. We've now done the first 10 pages. If we start having a look, at page 11, then again, look, you could try this now. I went through exactly the same, I went through this, the very first video part of the video when I went through page 5, which has these questions in them. Again, we're looking at sort of questions, similar questions to what we went through in this video. More algebraic fractions, substitution, sketching more lines, and finding midpoints and things. There's some questions which look a little bit different, okay, but they're very similar to what we've been doing. Again, sketching lines. So virtually, if you've watched both parts of the video, you really have been through every concept that we have for this unit. And of course, that's the last page there, 19. All right, so I'm going to leave that there. I look forward to seeing you all in class, and I hope you found this useful.